Hey friends, I am so excited to talk to you about my special interest today, horseshoe crabs. This is going to be part one. There's more to go. I got this in the mail today and decided I'm just going to start. So here is a horseshoe crab molt. Literally cutie patootie. These things are perfection. They have been around for 450 million years. They are crucial to why we are alive today. I have so much to talk to you about. There's so much to them, and I'm not even done yet. I'm so excited. So these are considered living fossils. They have hardly changed or evolved in their life. They just started good, came out good, stayed great. They've survived 4 mass extinctions, which I'm going to get into in my next episode, part 2. And then I'm going to kind of show a timeline of things and how much they have survived. So basically, here is its cephalothorax. These are its 2 compound eyes. They have 10 eyes. They have little eyes up here. They're simple eyes. And abdomen, here's a little hinge so that they can move. And then this is the telson. This actually isn't anything that they use to like pierce or dagger anyone with. I assumed it had some kind of like poison. Nope. It helps them so that when they go upside down, which is also the only way they can swim, it probably doesn't look, it looks a little, the only way they can swim is upside down. However, that is when they are vulnerable. So if they get swooped upside down, their tail kind of can dagger in to help them go back over. That is its main purpose. So here are the movable spines. These are really crucial to this little fella. So they're connected to the shell by the joints. If they lose them, they don't grow any back. So here is it's like a little lollipop. Okay. Isn't that amazing? I'm like in shock about this thing. It's so cool. This one said extra large. I'm gonna get all the sizes. So these help them to steer and stabilize while they're going through the water. They help dig for clams because they're sensitive. They're packed with mechanoreceptors. And so it helps them to sense water movement, vibration, and pressure changes. Insane. And they look like little teeth, to be honest. And they are great for defense because they are very much not easy to swallow. So, helps them out a lot. They are absolutely crucial to modern medicine. So a lot of people have seen like them hooked up and be drained 30% of their blue blood, which is copper based. And the reason why we need it for modern medicine is because they live in kind of like swampy, muddy areas, and it's just packed with bacteria. So if they got pierced and had like a little wound and bacteria got inside, they have nothing to be able to help it. So their blood has LAL, Limulus amoebocyte lysate, which clots the second it detects a bacteria and it traps it in the little clot. And then that's it. The bacteria can't do anything. So 100% of our medical devices, implants, IVs, have to be tested with horseshoe blood because it is so perfect and crucial to our safety. So we owe it all to these little fellas. And they're pretty tiny. If this is an extra large, this is still going to be immature. So it's still smaller than, I kind of thought. So these legs obviously help them move around, swim around. These inside legs are also teeth, which helps them to grab onto worms, little clammies, little like algae, whatever's growing around. And then it crushes it all up and shoves it down its little throat, which is full of gravel and stones. And then it swallows down to its gizzard. Gizzard? Like a bird. Okay? So, tweet, tweet. Okay. They are not even crabs. They are closer related to spiders and scorpions. So, interesting. They're not even crabs. Their eyes. These are the compound eyes. They have simple eyes up here. 10 sets of eyes. They have night vision with their compound eyes that boost light sensitivity by 1,000,000 times. Those eyeballs. So we have researched and we know so much about our vision because of horseshoe crabs, and there was a Nobel Peace Prize won for the research that was done, which I still need to read. So that's like so much left for part 2. So much left. Okay. So they will molt 16 to 18 times by the time that they're 10 years old. The way they molt. Most critters will get out of their bums and push out that way, like a spider. I think of that like that. These guys will pop open and then they kind of like push water inside to help them scoot out. So you can actually see this little dent right here and how it's open. Oh, I don't want to break it. But you can see how I can do that. That's where it opened up. So that was supposed to be sealed, but now it's dented in. So that's where it literally pops open and scatters out. So by 10 it's done, fully matured, won't molt anymore. So they have these mass mating events. And I think of it like that blanket of like little crabs I've seen on the streets and everything. During the springtime and into the summer, they will catch the low tide during the full moon and the new moon. And they have little males, which are smaller, will hitchhike onto her little back. And then she'll use the tide to scoot her onto the sand, and she'll dig a perfect hole, let me check my notes, 4,000 to 20,000 green eggs. And then the mate, whoever she allowed to stay on, will on the eggs, and then they go bury it and go to the next one until one mating season she can lay 100,000 eggs. So this whole event, it takes 4 to 6 weeks for them to hatch, or 2 to 4 weeks for them to hatch into tailless larvae. And so during this time, there's this shorebirds that depend on these. There's like a fly. The babies. And so there's a red knot shorebird, and they're going extinct. And so they are critical and crucial. And so they depend solely on horseshoe crabs to survive. The last thing I'm going to say, and then I have literally more research to do. I just wanted to do a part 1 little dive into horseshoe crabs. And this is where, I'm sorry if I say things wrong. So these are considered living fossils. They're arthropods in the family Lemmulidae. They're the only surviving Ziphosaurons. They are from the Triassic period. They're a subphylum of Anthropodae, which means like spiders. And then the reason why they're arthropods is because they're invertebrate and able to molt. So, spider. And the last living of the Ziphocerons. So, I need to see what else it includes. But if you think, like, what else do we have that's like this, like, I think of roly-polies. My friend was talking to me about that today. Roly-polies are also living fossils. So I'm going to do sort of a graph and see when we were a one little single-celled organism and then started branching out, I want to see where these branches led to and what didn't survive, because they spiraled me into another deep dive, which is a whole nother series, if I'm being honest. So buckle up for this, because it gets so interesting, you guys. I have been so excited to wake up just to learn more about this. I have not had this childlike wonder in so long. So I'm so interested to see the branching of evolution and what has survived, what had to evolve, and what didn't have to evolve, and then what evolved itself out. Saber-toothed tigers comes to mind when you think about something being so good at what it does, and it gets to the point where it did it all. It did it all. It ate everything. It got all the big food, and then it couldn't compete with wolves, coyotes, so they died out. I mean, it's interesting to see the things that don't need more. They just need to survive, and they end up being perfect. So it catapulted me into another deep dive. So I will go into more of that in another series soon. And then I will have part 2 coming up, because it is going to be a deep dive. This was a little twinkle. That one's going to be a dive in. So thanks for coming, and I'll see you next time.